Welcome to this video lecture. In this video's lecture, we're going to discuss Huffman coding techniques, which is present in the unit number 5. The course name is Analog Communication. Course instructor myself, Dr. K. Sivanandam from Department of Electronics and Communication Engineering from M. Kumarasamy College of Engineering. Already we discussed Tananfana coding. The coding techniques objective is we have to minimize the binary digit assignment for each and every message. So in the encoding techniques, we are going to assign binary digits for each and every messages. After that, we're going to find average length of the messages. Then we're going to calculate the entropy. From the entropy value and average length of the messages, we're going to find out the efficiency of the coding techniques. Our main objective is we need to increase the efficiency of the coding techniques. So here the initial stages we need to reduce the number of binary digits which is we're going to assign the messages. If we as possible as reduce the redundancy which is present in the coding, proportionally the efficiency going to increase. Now we're going to start the procedure which is present in the Huffman coding techniques with an example. The topic is Huffman coding techniques. So the given message set consists of 7 messages named as x1, x2, x3, x4, x5, x6 and x7. The next set is probability set. The respective probability value of each and every messages are zero point 0.4, zero point 0.12, zero point 0.2, zero point 0.08, zero point 0.04, zero point 0.08 and zero point 0.08. The first step is we need to assign the encoding for each and every messages. From that, we need to find out the average length of the messages, then entropy, finally efficiency. In the average length of the coding techniques, initially we need to assign the binary value for each and every messages. So here we need to reduce the redundancy based on the probability of occurrence. Now we will see the procedure how to assign the binary digits. So in the tabulations, the first column is messages, second column is probability. So now based on the probability we need to list out the messages. The list is based on the highest to lowest probability value. So from the probability set, the highest probability goes to message 1, that is 0.4. So the first probability value is 0.4, then respective message is x1. The next one is next highest probability value goes to message 3, x3. The value is 0.2. So the second one is x3 respective probability is 0.2. Then next probability value is 0.12. So the x2 message is placed in the third based on the probability value. Likewise, we need to list the messages in the decrement order. So next one is 0.08, 0.08, 0.08, finally 0.04. All these 7 messages are listed out in the decrement order. Next step is we need to club the final two probability value into single reduction. This is the first step reduction. So now I'm going to group 0.08 and 0.04. So 0.08 plus 0.04 gives 0.12. So in that second step, the 0.12 also we need to place in the decrement adder. So 0.12 will appear in the third position. The first position is 0.4, second one is 0.2, then 0.12. So now also the addition of 0.08 and 0.04 gives 0.12. So in this case, we will place the probability value in the fourth location. So first one is 0.4, 0.2, 0.12, then 0.12, after that 0.08, then 0.08, final 0.08. Next, second step reduction, 0.08 and 0.08 equal to 0.16. So 0.16 will appear after 0.2. So 0.4, 0.2, 0.16, 0.12, 0.12, kept remaining probability values as it is. Here the mistake is happened. So this 0.08 is already added. So this one is, we need to add these two values. So these two probabilities already added. Don't confuse it. This one will not appear here because we already added. Now we move to next step. So here next step is addition of 0.12 and 0.12 gives 0.24. So means 0.24 between 0.4 and 0.2, then remaining one is 0.16. Then again we need to proceed one more reduction. 0.2 plus 0.16 gives 0.36. Zero point 0.36, 0.4, then 0.24. Then again add 0.36 and 0.24 gives 0.6. Then remaining one is 0.4. So we need to continue this process until the probability is grouped into two values. So here we reach at this final stage. From the final stage, we need to assign the binary value. So here 1, 0, here 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. So next we go for coding for each and every messages. So now look at this table. 0.4, so only the final reduction we assign the binary value. So coding for message 1 is 0. So the probability 0.4 is until we reach the final reduction, it appear in the initial stage value itself. So therefore, message x1 carries coding as 0. So now use the two column tabulations. First column carries the code and second column is length. So first message code is assigned as C1, that is equal to 0. Binary value 0. Next message 2, that is x2. So here x2 equivalent probability is 0.12. So the first reduction is appear in the second reduction, that is 1. Then here in this stage there is no assignment of binary value. Then in the fourth stage reduction it is assigned as 0. Then again in the fifth reduction it is assigned as 1. So the second message carries the binary value as 1, 0, 1. Next message 3, that is 0.2 probability. So the 0.2 probability takes binary value from third reduction as 1, in the fourth reduction also 1, in the fifth reduction also 1. So the coding is 1, 1, 1. So third message coding is 1, 1, 1. Then fourth message 0.08, value 1. Then again here binary value is not assigned. In the third reduction it is assigned as 0, then 1, again 1. So the coding is 1, 0, 1, 1. Fourth message coding value is 1, 0, 1, 1. Now move to fifth message. Fifth message respective probability is 0.04. Its binary value is 0 in the first stage. Here no assignment. Here assigned as 0. Then it moves to here, no assignment. Then 0.4 here assigned as 0. The summation goes to 0.6. It is assigned as 1. So the binary value is 0, 0, 1, 4, 0, 0, 0, 1. Next message 6, 0.08, here assigned as 0, here no assignment, here 0, next step 1 and again 1. So 0, 0, 1, 1, 0, 0, 1, 1. Then finally message X7, initial stage, carries binary values 1, next step no assignment, next 0, then again 0, then finally 1. So 1, 0, 0, 1, 1, 0, 0, 1. So the first column is clear the coding from the previous tabulation. Now find the length of each and every coded message. The first message carries only one binary, so the length of the coding is 1. Then second message carries 3 binary digits, so length is 3. Third message length is 3. Then fourth message length is 4. Fifth message length is 4. Sixth message 4. Also the length of the final message also 4 bit. Next step is we need to find out the average length of the code. So here totally 7 message is present. So k takes values from 1 to 7. Summation over the limit k equal to 1 to 7 pk into nk. The first message probability is 0.4. Respective coding length is 1 plus second message probability is 0.12. Respective coding length is 3. So similarly, write the probability and multiplication of probability and respective code length. Third message probability is 0.2. Respective code length is 3. Plus fourth message probability is 0.08. And code length is 4. Fifth message probability is 0.04. Code length is 4 plus sixth message probability into code length plus seventh message probability into code length. So simplify this term, we get the final result as 2.48 bits per message. It indicates that each and every message originally takes us 2.48 bits. Next step is we have to find out the entropy of the messages. The formula is minus summation probability into log of probability. So here number of messages 7. So k takes values from 1 to 7. Now substitute the probability of each and every messages and take logarithmic of probability minus 0.4 into log 0.4 plus 0.12 into log 0.12 plus 0.2 into log 0.2 plus 0.08 into log 0.12 plus 0.04 into log 0.04 plus 0.08 into log 0.08 plus 0.08 into log 0.08. So the final value after the reduction is 2.42 bits per message. So up to now we have got average length of the code and entropy. Now we're going to find out the efficiency of the coding techniques. So here we know that efficiency of coding equal to entropy divided by average length of the code into logarithmic of m. So here we use binary coding techniques. So 0 and 1. So m takes value as 2. Therefore h of x equal to 2.42, h of x equal to 2.42 divided by L bar, that is average length of the coding is 2.48. So 2.48 into log 2. So base also 2, it takes value as 1, that is equal to 2.42 divided by 2.48, that is equal to 0.976. If suppose we're going to write this numerical value in terms of percentage, efficiency in terms of percentage, that is equal to 0.976 into 100, that is equal to 97.6 percentage. So here in this coding techniques, efficiency value we got as 97.6. Even it is how the redundancy, the percentage of redundant bit which is present in the coding is 1 minus efficiency, that is 1 minus 0.976 gives us 0.024. While converting in terms of percentage, it gives us 2.4 percentage of redundant bit is present in the coding which is assigned using the Huffman coding. Dear students, from the video lectures, we're going to discuss during the class hours with another type of examples. Thank you very much.